Hello, everyone. We are live, and I would like to start this meeting by saying thank you, grazie mille, thank you, Francesca Moglia. While the whole industry was on holidays this summer, she worked really hard on bringing 3 amazing success stories on the cleanest topic for the laser industry. On Monday, September 20th, our online technology meeting will focus on recent advances in laser ablation and laser cleaning. We'll inspire the epic universe with these 3 success stories. Number 1, Coherent and Fraunhofer IFAM. Carbon fiber reinforced plastics, or CFRP, is the magic word for reducing the airline industry's carbon footprint. They combine high physical strength with lightweight. The lower the mass, the greener the plane. However, the chemical release agents used in separating individual CFRP parts from the molds leaves a residue on their surface. This can interfere with the addition of protective coatings that must be applied to the wings or the fuselage of the plane, so cleaning becomes essential. The excimer laser has emerged as the most promising cleaning tool for this task because of its power and the fact that pulse light doesn't damage CFRP fibers. However, the challenge is that most excimer lasers are physically large and heavy. That means they can't be mounted on a robotic arm. In our online technology meeting on September 20th, Coherent and Fraunhofer IFAM will discuss their work to develop a smaller, simplified excimer laser-based solution that lends itself to robotic automation. Number 2, cleanLASER and LavaX. In the welding business, considerable effort is made to eliminate so-called weld spatter. In simple terms, those are the little balls of metal that fly during welding and attach themselves to anything nearby. cleanLASER and LavaX have partnered to ensure that welding spatters are a thing of the past. The solution involves laser welding in vacuum, which means the laser power can also be significantly reduced with cost and environmental benefits. And number 3, for jet and tire manufacturers. At Epic, we love automotive. Leading tire manufacturers need to add functionality to tires after the curing process. That includes self-sealing materials to heal punctures, noise-canceling foams to quieten the interior of the car, as well as sensors to monitor tire conditions. So laser cleaning from companies like Jet makes a tire spotlessly clean to guarantee perfect adhesion. Are you impressed like me? I am definitely not missing this one. And if you are a laser manufacturer, a system integrator, end user, or play a role in the supply chain, you should join me. Sign up immediately to follow with our experts in the Epic Zoom room during and after the meeting on Monday, September 20th, or you can always catch up in our on-demand YouTube channel. And you listen to our call. We were calling for laser manufacturers, system integrators, and end users, and we have all of you here in the Zoom room. Thank you very much for that. The purpose of the next 2 hours is to find business opportunities. So here is your task. At the end of the meeting, I will ask you, you generated at least 1 business opportunity for these 2 hours. And if you say yes, that will have been a very efficient use of your time. We'll start on time, we'll finish on time. My name is Jose Pozo. I think you already know the fantastic team that we are here representing. We have people from the marketing side, from the technology side, 12 people who dedicate their life, 13 people who dedicate their life to the photonic industry. We organize events, we provide access to a network, we help you raise capital, we have the biggest website to find a jobs in photonics, and we have fantastic and exclusive market data for our members. Today we are on the 3rd chapter of this season 5 for the online technology meetings, laser ablation and cleaning. Pay special attention what is happening on the 22nd of September Wednesday, on our Mid-Year Alliance. Our Mid-Year Alliance, the companies in the mid-infrared segment are coming together to discuss environmental monitoring. If you are a manufacturer of quantum cascade lasers or mid-infrared fiber or anything from CO2 lasers to any generation or reception of mid-infrared wavelengths, do not miss this one. But today we are talking about laser ablation and cleaning. If you are in the quantum industry, also in 2 weeks, we have our first quantum technology meeting of season 5, atomic clocks and network synchronization. But I want to talk only today about laser ablation and cleaning. So I would like to say, first of all, thank you our partner in crime today, AILU or AILU, the way that you know it. The Association of Industrial Laser Users is partnering with us in the organization of this event, which would not be possible without the support of our sponsors today, Focuslight, also the company that is the mother company of Limo. If you're looking for semiconductor laser diodes, so the MicroOptics package those semiconductor laser diodes. Focuslight is the company that you should partner with. If you're looking for aspheric optics, freeform optics with the highest precision in the market, asphericon in Jena is your partner. You're looking for a specialty fiber for any laser industry, active fiber for EDFAs, or any fiber sensing solution, OFS, a Furukawa company. If you are looking into ultra-fast laser systems and lasers that actually satisfy the need for the academic and R&D sector, Lithium Laser is your partner. If you are looking for IBS-coated laser optics with super low absorption and integrated loss, Optoman, all the way from Switzerland. And finally, last but not least, all the way from Neuchâtel, the success story of the European micro-optics revolution. SUS MicroOptics has actually made a huge impact in the development of micro-optics at wafer level. And most important of all, sorry, all the sponsors are great, the partner is great, but most important of all is our laser guru at EPIC, Dr. Francesca Moglia. Dr. Francesca Moglia, buonasera. What's going to happen today?
Thanks a lot, Jose. You're not fast enough in Italian, I see. Thanks for the nice introduction. So this is, as we heard already a bit from the video of Jose, what we will talk about today. So first, Dave, our collaborator for AILU, but then we see actually that these are not the only 7 speakers here today, because if we go here exactly to this slide, you will see that this is all of you signing up to this meeting, really distributed in a very nice way on our supply chain for laser ablation and laser cleaning. So of course, it's very important that we have some end users here in the room that can understand a bit, at least tell us what are their needs, and also we can tell them how we can help them. And of course, here, this topic really has a good connection to not only the equipment manufacturers that are, of course, here, many of you industrial laser systems experts are already in the room, but also there are advanced laser manufacturing services that for laser cleaning and ablation are really a typical service, one of the typical ones that also our EU-funded project Pulsate is also supporting. And then, of course, we cannot go to the equipment and to the cleaning without the laser itself. So it's very good that we have many laser manufacturers here in the room. And then the rest is not that it's less important, it's very important. That is the full components. And of course, experts that are here are for this part. Also, our added value distribution is very important. And last but not least, R&D, because the laser cleaning and ablation of today wouldn't be here without the support of the R&D that is behind it. So now, I guess I gave a nice overview of who is here in the room.
Do you believe that every Monday at 3 o'clock we organize an OTM like this one? Every Monday at 3 o'clock we have an entire supply chain. By the way, welcome Nitty Gritty. It's a very fantastic name for your company. Thank you for joining the meeting. I would like to say that this slide only corresponds to the companies that join our OTM today, that register for OTM today. If you're an EPIC member, but you miss your logo at this slide, only means that you forgot to register. Don't let it happen again. And also I would like to remind everyone that you have to look your best, because this meeting is live streaming YouTube. Hello, YouTubers. If you want to have a question for any of the speakers today, just write it in the chat. If you want to get in touch with any of the participants, drop me an email, jose.pozo@epic-aso.com. Tell me why you want to get in touch with them, and I will make sure that you get properly introduced. I think it is time to get the meeting rolling. We did as fast as we can the introduction, because we are aware that we are the least important people in the room. Let's give the floor to the people that really matter. I want to welcome to an EPIC meeting for the first time the Executive Director of the Association of Industrial Laser Users, AILU, Dave MacLellan. It's great to have you with us.
Thank you very much, Jose, and thank you, Francesca, for the introduction. And we're very happy to be partners in this technology meeting. We also run online meetings, and we share a lot of the same ideas and objectives as EPIC. And I'd like to just spend a couple of minutes to tell you a little bit about more about who we are and what we do. So as Jose already introduced me, I'm the Executive Director, a job I've held for the last 6 years. And AILU is all about connecting, empowering, and guiding people who use lasers. And first of all, what is AILU? We were founded in 1995, so we are 25 years plus one. We were going to celebrate our 25th anniversary in big style in 2020, but the virus came along and changed our plans a little bit. But we are fundamentally where industry meets academia in the field of industrial laser material processing. And I think if you were to look at EPIC, you would say that EPIC is obviously involved in photonics industry. And so therefore EPIC is a wide organization with a large number of members and a large supply chain. AILU, by contrast, is perhaps more deep because we specialize in one area. We can go deeper. So we have more members in the field of industrial laser material processing, in manufacturing, in research, and in the job shops and the end users who are using lasers for manufacturing. We have over 300 members, and they come from 13 countries. So that's a little bit about us. Because we are now 25 years old, it was a good time to take stock of why are we here, why do we exist? And we looked at our purpose and our vision and our mission just to see if we are happy that we're still pointing in the right direction and moving in the right direction. And we rephrased our purpose to be to grow laser adoption by connecting, empowering, and guiding both new and existing users of industrial lasers globally. When we started 25 years ago, there were not nearly so many users of industrial lasers around the world, and there was a lot of necessary education had to go on. Now we find there are lots of existing users who we can help to develop, and some new users that we can still encourage to get into this field. And our vision is to maximize the benefits of industrial laser technology to society. I think there are a lot of imperatives in the world at the moment towards green energy and improved transport and all kinds of other connectivity issues where lasers can be involved. And our mission is to support the acceptance and progression of laser technology through fostering and raising awareness of laser technology and applications, and through connecting academic and industrial laser communities. And why should you join AILU? A lot of you are members of AILU already, but I noticed that some of you are not. So I'd just like to encourage you to get in touch and find out a bit more about what we do. But essentially there are 5 key benefits. Firstly, we can improve your network by connecting you to other people that you may not already know. We can increase your knowledge through the events, workshops, webinars, exhibitions, and publications that we are involved with. We can supercharge your career by connecting employers and employees and finding jobs for candidates or filling vacancies for organizations. We can help you to share your research and maybe to connect with partners to form new projects. And last but definitely not least, we can help you to grow your business. We're very much involved with some of the end users of lasers in manufacturing, in the UK, especially in job shops, but globally as well. And finally, just before I sign off, I'd like to just invite you to our next event, which is going to be our first live event for 2 years. And it's going to be on the 6th of October. So that's in 16 days from now. And it's going to be at Cranfield University in the UK. And the theme is digital technology in laser manufacturing. So if you'd like to know more about that, then do reach out, get in touch. Contact info is there on the screen. And I look forward to welcoming you at that event in person. Or if you can't attend in person, there are options for a hybrid event too.
Thank you very much. I love that we're working together. At the end of the day, as you said, we are perhaps the most important two laser associations. Dave, maybe I will challenge you one day into finding 5 people in your staff that know better lasers than Antonio Raspa, Francesca Moglia, Elena Beleskaya, Sana Pica, and myself, Jose Pozo. We are also a very deep and in-depth association. Looking forward to do more things with AILU. But now the room goes to the success stories of Europe. Those companies that we know very, very well at Epic, because our job is to know the 749 members as deep as possible. And the floor goes to our key member in Excimer Lasers. And I would like to say also my personal friend, Ralph Delmdahl. Ralph, thank you very much for joining this spectacular meeting. The floor and the attention of everyone goes to your primary love in life. I know that. Excimer Lasers, the floor is yours.
Thanks a lot, Jose, for this kind introduction. I'm very happy to be here and be able to share the latest in system technology of Excimer lasers together with our many years partner, collaborator, Thomas Lukasczyk from the Fraunhofer IFAM. And actually our premises in Göttingen, they just celebrated the 50th anniversary. So it's a special year for us. And so let me start with the main advantages of Excimer lasers before we go over to Thomas and go really into the details of the novel system approaches. Excimer lasers provide highest resolution and layer selectivity in surface processing. And that is, of course, mainly due to the ultra short wavelength. So many people these days talk about ultra short pulses, femtosecond, picosecond, but here we are really at the ultra short wavelength edge. And that means Excimer lasers provide 193, 248, 308 nanometer, depending on the gas which is used. And by that, we have a really shallow penetration depth into any material, polymers or other types of ceramics, for example. So typically the depth per pulse is just below 100 nanometers. So that is really vertical resolution. And if we want, we can also add lateral resolution. The other thing is, so it's like a package which is provided by the Excimer lasers, is that it's very easy to make a top hat profile from this laser because it's a multi-mode laser. And with a top hat profile, you have main advantages being if you want to fill a large area with top hat, say square or rectangle spots, you have a high fill factor and you do not need high overlap of the shots. So you're very fast and you really have a smooth application of your energy density over the area. And also you avoid superfluous energy in the center of your intensity distribution, like in Gaussian profiles. And so that also helps to be very layer selective. So another advantage is the scalability. And that really sets Excimer lasers apart. If you go, this slide, you see it's really a huge range of scalability we achieve with this laser technology. Of course, everybody talks power. So here we span from 1 watt up to beyond the kilowatt range nowadays. But also very important is the pulse energy. And that is really unique to Excimer lasers. We can easily go from systems putting out 10 millijoule tabletop systems like the ExiStar, which is installed at the IFAM Institute, Fraunhofer IFAM, at repetition rates up to kilohertz. But we can also go with equally compact systems up to several hundred, 750 millijoules, for example, and really produce decent field sizes, large field sizes. The systems we typically use for this are shown in the next slide. Here you can see several power class optical systems together with the Excimer laser. On the right side, we see a compact system. So this system can put out up to 750 millijoule per shot. and we fold the beam above the laser, and then it goes down again, and then you can, for example, make a square field or whatever and treat your sample. We can also put the beam system in front of the laser, like on the top. That would be like 100 or 300 watt system. And to the right, you see a subsystem which combines many beams. You can see the beams going in. In that case, these are 4 beams. So that's 3.6 kilowatts max can go in of power and be combined and really make huge fields, long lines. So such systems are used in the display industry. And all these systems they vary in appearance, but you can see or they combine a similar technology for beam forming, beam shaping. So we have an attenuator for seamlessly setting the energy of the beam, and then beam splitters, for example, or telescopes to shape the beam. And then as a central part, the homogenizer, which really makes the flat top beam profile, and then project the flat top beam onto the sample, demagnify it, so we achieve the fluence we require. In the next slide, we see or what I call giant footprint processing, which is essentially done. So you see the raw beam profile on the left, and then the beam shaping optics shape a very homogeneous line, which is essentially an extended rectangle, because also the short axis is flat top, or a square or rectangle. And then you can do 2 basic approaches, like, for example, in this wafer case, you can scan a line over the wafer, or you can do a step and repeat and meander back and forth with a square field. So in these cases, which is classic excimer surface processing, the beam is always static. And Thomas will show you now how you can also have approaches where the beam is moving. So with that, I hand over to Thomas. Thank you.
So Ralf, thank you very much. So you have seen that via changing the shape of the laser beam, you can go from a step and repeat method to a line scan method, and thereby treat a larger area in a small amount of time. And we have applied that. We have combined it also with a scan head. And here in this video, you can see the treatment of a CFRP part. It's a part from the airplane industry. And the main advantage here for the UV excimer laser treatment, you have a very high grade of absorption directly here in the epoxy resin material. But if you choose an excimer laser treatment for CFRP treatment, you have to choose the right amount of energy which you apply on the substrate. So if your energy is too high, you will remove the resin material completely around the fibers, and thereby in mechanical load, you will tear out the fibers from the material, and this leads to damaging. And therefore, you typically use a lower amount of output energy for your laser treatment than the whole system could apply. So in this case, we used a Compex Pro, and we applied typically 40 to 50% of its complete output power. But while changing with changing the shape of the laser beam, and also with the scan head, we were able to increase the surface rate from roughly 7 square meter per hour to up to 11 square meter an hour. If you want to have more flexibility in your treatment application, you can also move the laser, but also the part you want to treat with a robotic automation. You can see it here. In this case, the robot takes the part and it moves it in front of the laser. In this case, a smaller version. It's the XC-Star from Coherent. And you can see how you get here a very quick treatment, but also a very selective treatment of the substrate area. The effect can be seen here. On the left side, you can see the laser treated area, which shows a very good wetting behavior. On the right side, the untreated surface. And that means in total, you can use UV excimer lasers for robotic automation. You can use it for high process rates. and you can treat CFRP parts without fiber exposure and so in a damage-free way. So since I'm new here around in this round, I want to show a little bit more what we are doing at Fraunhofer IFAM. We are mainly focusing on surface treatment, and that means we are focusing on surface modification. Structuring, polishing, varying the surface chemistry. We are also focusing on coating removal, decoating, cleaning, and labeling. We have also some smaller topics in terms of surface drilling and cutting, and also some forward transfer applications. Not all of these applications we are doing with a UV excimer laser, but another example is shown here to the bottom left. So that's a coloration of titanium. We are modifying the surface oxide layer, and thereby we get a color labeling of the substrate material. Some of the applications that are shown here, we are also applying IR lasers. Just to show an example here, that's a very special 3D optics with a 360-degree mirror head at the end of the optics. And thereby we are able to do a treatment of three-dimensional structures, also large-scale structures. So in this case, the part you can see here is 2.5 meters long. And again, we have here a robotic treatment. So just to summarize a little bit what we are doing at IFAM. So what is very important, we are not developing new laser systems. We are just a technology and process developer, and we are using industrialized systems. We are mainly working at the moment with two different types of laser systems, so IR lasers and UV lasers. In the IR laser region, we are working with cleanLASER systems. You will hear a talk from the company cleanLASER later on. And we have also fiber-guided femtosecond laser from the company IPG with a Novanta scan head. And for the UV lasers, we are solidly working on coherent pulsed excimer lasers, mainly in the wavelength region of 248 nanometer, but also 193 nanometer. And we have a lot of supplementary at our institute, laser cells with portal systems, robotic treatment. We can also combine the laser treatments with other physical treatments, like for example, plasma film coatings. We have surface analysis and inline monitoring departments in-house. And with that, I want to thank you for your attention, and Ralf and me are open for your questions.
Thanks a lot, Ralf and Thomas. So it was a very nice story told for us. So also with an extended family. So we hear later on also from other collaborators of yours. So very nice to have this big picture of what you are doing together. So now, as I promised, we make questions now to both of you. And considering that is a very suitable question for both of you, the question is, what can you do for them and what can they do for you? That means this audience here. How do you think you can collaborate with all these people here in the room? Maybe we start with Ralf, so we do just chronologically. Ralf, what do you think is something that all the supply chain can help you with?
Yeah, so we can supply all kinds of excimer lasers, but also optics, so optical components, but also custom optics to shape any type of beam for various applications. What we like to add to our technology or to benefit from is really approaches such as the IFAM is doing, how to more flexibly operate excimer lasers for example 3D parts and so forth. Because we ourselves, we are mostly providing systems for like wafers or panels which are flat and they move below the static beam, but there's a lot of applications which benefit from the short wavelength, where you really need the short wavelength, and that Thomas showed. But still, then you have to overcome system challenges.
Okay, and then Fraunhofer, so your colleagues are already supplying on everything on this, or do you have something that is maybe some external issue that you might have? So we know, yeah, you make your optics also on your own, but it's something also excimer wavelengths are very well known since a while, but is there something that with the power maybe that you now need, because I saw you're reaching really high power as well, for the coatings, for example, because here we have the coatings guy as well, so just to to excite them as well.
Was the question for Thomas?
So if there are challenges that you are not dealing with yourself, but you would like to propose to the audience here, like for example on coatings for the optics.
Okay. Yeah, these we produce ourselves, but we also have suppliers. So we are generally also looking for suppliers always, because when you put high power through coatings, you need, of course, high quality coatings, and for the UV, and sure, that is also always something we can talk about.
Very good, you know, and you see, the shy people get then excited when I put the let's say, the starting of the fishing. So Constantina says something to tell you, for example. Constantina, make your comment yourself and question, please.
Yeah, hi. So I'm from Optoman, and Optoman does optical coatings. So I have a question. So how long the UV optics lasts in your, let's say, typical 1 kilowatt excimer laser?
They last many years, actually, more than 10 years. But that is also due to the design we choose. So we design the beam path such that we do not go above the damage threshold. So that's also a question whether you keep your beam large before it goes through the optics, and only after the optics you focus it. Yeah. So this is a question of the design, and typically in our systems, UV systems, they last, you can almost say forever. I mean, like 10 plus years.
Okay, it seems you have sorted these problems.
Yeah.
Thank you.
Very good. Very good. Then maybe we can move forward. So of course, Ralph is here. Let's not forget about him. But maybe we can talk now about Thomas and his expertise. So we saw that basically Fraunhofer IFAM is supporting towards this laser cleaning activities, more on the also automatization part. But the same question goes to you. Is there something that this audience here can help you with as well, and that you can basically help a bit more? We heard about the aeronautics sector. So if he's also focused in this direction, or if there are other applications that you are working with concerning, of course, laser ablation and cleaning, this is the time to put some wishes in the room.
Thanks a lot. So as I've already said, we are technology and process developers. So we are not dealing with the laser system itself. So what we can offer, we have a very deep understanding of the laser substrate interaction. That's our main point. That's the thing we understand, especially in terms of adhesive bonding technology. So Fraunhofer IFAM is the largest independent research facility in Europe for adhesive bonding technology, and that's the field we are coming from. So what I think maybe EPIC can help me. So we are always looking for new types of applications for our topics. We're always looking for new research topic. So what is interesting for the audience, what are topics maybe laser treatments should be used for, but they cannot be used for at the moment. So that's something I'm very interested in.
Perfect. Then it's a very good point. So maybe, Jose, it's time now to put a bit of spices in the room, right?
First of all, Francesca, thank you so much. Your energy, you're a rock star. Yeah, I love it. I love having Francesca with us. But I have to say, my passion is laser scanning. I share that with many members in the room, and I would like to address this topic now. Laser scanning. I love the slide here, in which we're talking about the laser scanning process for the UV excimer laser system. And there, I think there are many rooms to be open for cooperation. We have we have companies in our network like NextScan. We have also, of course, relays. I would like to understand first from you, Ralph. It is said here that the current product used is the Coherent Complex Pro. Is there any challenges, any room for cooperation into the laser scanning process for a UV excimer laser?
Yes, I mean, so the Fraunhofer IFAM has done this sort of prototype system, has worked it out. We also provided optics for that, but to really say, yeah, turn it into industrial system. That is the part where we need help or an additional partner to really turn it into an industrial system.
I love that answer. That's the perfect answer. I'm gonna go to Thomas. Thomas, could you share with us like one or two technical challenges? Because I cannot hear this from Coherent, so that's why I love that they can ask Fraunhofer IFAM this. One or two challenges that perhaps the partners that we're gonna find for Coherent can help with.
I think one of the main problems for the scanning system was if you do the scanning process with the excimer laser, you have a change, for example, in the size of your laser beam the more you scan to one side, and that was a really critical point. And I think there's also some optimization to be done. So, for example, some company who can handle the software part, who is really familiar with scan topics, also with rather large working distances. That would be a good thing to have.
We are going to find some partners first. The first one, I think you maybe already know, but I'm extremely excited at what they are achieving all the way from Netherlands. Next Scan Technology. Lars, goedemiddag. There are some challenges here related to keeping the beam position constant over the entire platform. Your polygon scanners are the magic trick here, right?
Yeah, so that the topic is full telecentricity, and the challenge is on how to address a constant spot geometry over the complete substrate. The thing is always so or at least the thing is with excimer is of course it's a special wavelength. You need glass optics, so that's for sure, and maybe for the people who are not into this kind of topics or so, NextScan is having a full telecentric optics, but it's metal based, and if you want to transfer that to glass based, that is a quite an expensive exercise, as Coherent well knows, and also Fraunhofer knows, especially when using mirror optics. So there are solutions, but as usual, it always starts with a business case and see if those kind of investments are justified. But again, from a technology point of view, it's possible. And of course, if there's a set of parameter settings which we can convert into a optical solution, that would be interesting to discuss, of course. Yeah.
Lars, look at this slide. They are targeting 60 by 60 centimeters square, and they want to go 11 square meters per hour. And those numbers are very similar to one success story you are cooperating already with, I can say because a European project, the Lampas project, and you are cooperating already with Bosch, with Trumpf. Is there a potential room for cooperation here, taking into account that these very similar numbers in the challenge for the throughput?
So it all depends on, okay, what is the, if you look at how can you achieve a specific throughput, it depends on pulse repetition rate and spot size. The smaller the spot size, the more repetition rate you need from the laser, so the pulse frequency. The larger the spot size, the less pulse frequency you need. So it is finding the balance in how fast can a laser switch on and off, and how large are the spot sizes, and that is it needs a systematic approach. So it is laser, it is optics, it is motion control, it is software, it is the GUI. Everything needs to be a harmonic solution to make things work. So it's not that straightforward to say, okay, we can do this, we can do that. We need a systematic approach with all the partners involved, just like Lampas.
There is a company in our network in the European industry, all the way from North Munich, which is called Relays. Bernhard Dauner is here with us. Good afternoon, Bernhard. Thank you very much for joining. We have a laser scanning challenge, and I don't know any better than going to you now and tell us how you could help. This is their target. They want to go to 11 square meters per hour. They have a excimer laser in the nanosecond regime. Can you help?
Yes, thank you very much, Jose. So I'm sorry, I'm sharing the office and there's some other talks that you might be hearing now. But coming to your question, Jose, so finally I can only add on to the same answer than the next scan. So it would need a systematic approach. We would need to verify the laser parameters, the field parameters, and work together finally with machine builders or integrators to solve that application well. We are focusing on galvo scanners applications, not on polygon scanner applications. And I think we have very fast galvo scanner solutions on the market. So that's always a trade-off. And then the comparison, galvo scanners versus polygon scanners, when does this application really work well? So we're happy to discuss it in a more detailed manner, but I think as a general answer, it's difficult to answer it right now.
Of course, Bernhard, it was already highlighted between the lines by Thomas and Ralph that it's also a software challenge, and I know that Relays has been investing heavily on that side. Could you comment on that? What is the position of Relays now helping companies that come up with that challenge? It's also a software challenge.
Yeah, that's a very good question. Thank you for the question. So for Relays, our approach is definitely to solve, let's say, some at least of the applications by intelligent software approach. So we have a comparatively quiet software department, but basically, of course, we Relays would need to program and implement specific features in our control card solution. That's what we are currently doing for different applications. And right, so if there would be any, let's say, very intelligent software approach for this specific application, we would be happy to have a look at it. And if the business case is the right one, of course, then we would also invest in this.
Bernhard, thank you very much for being here. I want to give the floor to one company that I just love to the core, Excelitas, Keyoptic. Matthias, thank you very much for being with us. I think you have a lot to add to this topic. What's on your mind?
Yeah, hello, everybody. So my question to Ralph, Coherent, is, are you facing some problems with the UV? So facing problems like contamination, like low outgassing process, are you working in the clean room? What are your requirements for the optical systems inside?
Yeah, the optical systems are usually capsuled, either in aluminum, as I have shown this slide, or maybe plexiglass, whatever. So they are encapsulated and then flushed typically with nitrogen, and that is normally sufficient. There's nothing more specific to do for these systems. What I think really, and what I hear here from these discussions, I mean, that is really for us the first step together with the Fraunhofer IFAM to really show that the excimer laser can also be used in a more flexible, say, solid state like way of processing, still keeping a top hat profile. With these problems of, as Thomas said, to keep the profile via the scanning and so forth. I think that is something we need to show first, and I think that has been done, and then go further from here, software-wise, automation and so forth, and of course with the business case.
Thank you very much, Ralph. Thank you, Matthias. There is one final question for you, Ralph, and also for Thomas. It's coming from one of our favorite consultants in this field. It's coming from Andrew Beers from ABM Consulting. Andrew, good afternoon. Andrew has the question, but I'm not sure he has the sound. Luckily, I know the question. Is there an optimum wavelength for silicon cleaning technology?
I have to make another question. So to clean the silicon from the substrate or to treat silicon?
No, for cleaning the silicon from the substrate.
Okay. I don't think there's an optimum wavelength, but I think 248 nanometer is quite a very good one, since you don't need some gas like nitrogen in your optics that keeps oxygen out of your treatment area, and you can have a very effective treatment with 248 nanometers. So I think it's a good way between all the treatment effects.
248 nanometers. Thank you very much, Thomas. That's what I love about this meeting, technical meetings with the right answer. Do you guys like weld spatters? Because I love them. They look pretty and they stick everywhere. The next success story is coming from cleanLASER and LavaX. They're going to tell us how they use lasers to remove weld spatters. I can't wait. Let's give the floor to our next success story. Let's give the floor to Tobias Weichert from cleanLASER. The floor is yours.
Yes, thank you very much for the introduction. I am happy to take part the first time at the EPIC conference today in combination with LavaX, Benjamin, my colleague. And in the next few minutes, I will present you our activities in the e-mobility, in the automotive industry, focused on the topic for hairpin decoating. And please let me start with a short overview about the company cleanLASER. cleanLASER has now 25 years experience on the field for laser surface treatment. We are located in the west of Germany, close to Aachen, a medium-sized company founded as a spin-off from Fraunhofer Institution for Laser Technology, 140 employees, and we can support the complete process chain from application testing and qualifying, R&D and design development, the laser and machine production, plus service and training for sure. Okay, as I told you as the entrance, I'm focused on one topic. I share here with you an overview what kind of applications for laser cleaning are possible in the e-mobility. And you see that there are a lot of applications and activities possible, which support to build up such an electric car. And we have applications in the field of the battery packaging, the battery manufacturing, also in the manufacturing of, let's say, control units. And for the new era of powertrain, the electric drive. And this is exactly the topic for the hairpins. And let me start with the background of this technology. Hairpins are usually used to build up electrostators to produce electromotors. And this hairpins are made of base material like aluminium or also copper. And they are coated with a temperature resistant plastic, let's say. And there are many different kinds of plastics. And now the challenge is to remove partial segments of these wires or wire pieces to have a very good surface quality before a welding or soldering process. And exactly here, this is a challenge for laser because you have to treat the wire complete around, means from all four sides. And you have also the requirement from the market that there's not a law to destroy the material itself or to have a degradation. And that the process is running very fast on the fly inline in this complete manufacturing machine. And this is challenging because we have always to find out the right parameter setup, because the coatings are very different. And what I have written here on this slide is an example for coated copper and an aluminium. And we use normally lasers with an average power between 200 and 500 watts, which allows an removal of this coating without damaging or modification of the blank material. This process is not possible to treat only in one pass. This means we have here the challenge in the setup or in the parameter finding that you have to do several passes over this area to have a very clean surface in a good quality. And the results is that you, the need is to have a complete removal of this coating and then very good cleanliness. And therefore we have different measuring systems to use. And one requirement is to have a measuring about the fluorescence measuring tool of a value smaller 5. And this is possible with this kind of parameter setup technology. The speed varies and is depending for sure on the layer thickness you have to remove and also the kind of the plastics. And in one case, or a typical case, is a copper coated with a polyamide, 80 to 90 micron layer thickness, and the length of 10 millimeter, which you have to decode, can be applied in less than 0.6 seconds. This is what you can see here in this next video. And this is a complete machine chamber where the wire is going in and going out and feeded with a special feeding system. The speed of such a wire, you see here, can be up to 1 meter per second. And you have to treat during the movement of the wire partial segments to clean around that it could be prepared for the next process, which will be the welding. And this is what I have here on the right, a microscope picture of a welded aluminium hairpin done by LavaX. And in this case, Benjamin, I will hand over to you to finish this success story.
Thank you very much, Tobias. Just share my screen. Excellent. So thank you very much for the kind introduction. My name is Benjamin Gerhards. I am head of R&D at LavaX. Maybe at first I say some words about our process, that is laser beam welding in vacuum. Therefore, I want to draw your attention to this high-speed video. You can see a comparison between laser welding at atmosphere on the left and laser beam welding in vacuum on the right. And you can see the distinctive differences between those processes. At first, we do not have a vapor plume above the capillary. Second, we have a vapor plume above the capillary for the atmosphere welding. Second, we have spatters that occur. And third, we have quite a large molten pool with high dynamics in it. And on the right side, with the same parameters, you can see that we have a significantly smaller molten pool. We have no vapor plume above the capillary, and spatters that occur are quite tiny, so they do not adhere to the surface. And all of this is due to the reduction of the evaporation temperature of materials such as steel, iron, aluminum, and copper. If you look at the cross-section here on the right picture, you can see that when welding at atmosphere, we have quite a large molten pool. And when welding in vacuum, we can use the energy to go deeper into the material. So with just 500 watts of power in stainless steel, we can achieve a penetration depth of approximately 3 millimeters. So we have several advantages for our process in combination in the contrast to welding at atmosphere. For example, we have the increase of quality. We have no cracks or pores. And this also applies for alloys or materials that are difficult to weld. We have the avoidance of spatters. If spatters occur, they are not adherent to the surface. We do not have any vapor deposition on the material surface or oxidization. and we have a very economic and ecological process because we have low laser power machines, and we can achieve the same welding result with lower power. Also, we have a very scalable process, so it's possible to weld foils of 10 microns thickness and go up to a penetration depth of 100 millimeters in steel, for example. So, but we also have several rules of thumb that also apply for the vacuum process. And this is at first the clamping device. So we need a zero gap, nearly zero gap bevel preparation. The gap bridging ability for our process is kind of poor because of the smallness of our beam. So it might pass through those materials that we want to weld without melting them. And the other is that we need a very, very good bevel preparation in terms of pollution. So we do not want any greases or any oils or any organic materials inside of our bevel preparation, because those materials, they expand when the laser beam goes over them. And this leads to a large amount of spatters and in the worst case of weld pool ejections. So in the case of welding those copper hairpins, for example, we have a video that I want to show you that was made by our cooperation partner 4D, and it shows when the laser beam's trajectory goes over the gap, you will see a large weld pool ejection like this. And this is due to the rest of insulating material that is between those two pins that are welded. And you can see not only that we have spatters that occur that might lead to short circuits somewhere in the stator, but also we will have significant pores that are in the molten pool and that will be trapped in the material and therefore reduce the electrical conductivity. If I may draw your attention to this, those pins were preparated by cleanLASER, and therefore you can see we have very, very low amounts of remaining material on the surfaces. And in combination with our very stable process, we do not get any spatter. So short circuits are not an issue here. And also we do not see any pores that occur. And this is also due to the fact that in the vacuum we have low heat conductivity to the atmosphere because it's missing. And therefore the molten pool stays liquid a little bit longer. And pores that are in the molten pool, they have the ability to gas out of the molten pool. We can use for this welds, when welding, for example, the oxygen-free copper grades, a 2 kilowatt laser with a 550 micron diameter. And we will just need 180 milliseconds for the weld. And this is the result. I think you can see there are no pores, nearly no pores. And those pores that we have are very, very small. This is due to the combination of the very, very good preparation of cleanLASER and our high quality welds. We can also do the same with a multi-mode laser. And this time we used a disc laser by Trumpf. And this here is a weld that was conducted on ETP copper, which is not very common. Most of those car manufacturers use the oxygen-free grade because of the pore formation that you usually have when welding the ETP copper. But also in this case, you can see with adapted process parameters, there are very, very tiny pores that do not really reduce the connectivity significantly. And the last example that I want to show you is, again, in cooperation with cleanLASER, and here in this case, PEM of RWTH Aachen. It was those aluminum pins that Tobias also showed. And I want to show you another high-speed video of this because it's quite impressive in my mind. If you know something about laser beam welding of aluminum, then you know that aluminum is very, very susceptible for pore formation. And the first thing I want to draw your attention to is that there are nearly no spatters that are occurring. And also that what I mentioned earlier, the molten pool stays liquid a quite significant amount of time. You can see the formation of the oxygen layer quite swiftly here because we had the lighting for the high-speed images transferred into the vacuum, therefore had a small leakage. And yeah, now you can see it. But it's still liquid, and you can see now the pores gassing out of the molten pool. And this is quite a huge advantage of our process. So you will not be able to weld those aluminum hairpins when using the common conventional atmosphere process. And if I may show you the image again that Tobias showed you already this year, you can see the very, very high quality that you can reach when using the right preparation of the surfaces by cleanLASER with our high quality welding process. So thank you for your attention.
Thank you very much. Thank you very much. Another nice success story with the "we cannot work without you" message at the end. Thanks a lot, Benjamin. Yes. So now I see there is already a question, but wait, Matthias, let's go first in order, because we know now here we heard that nice collaboration story, but there must be something that is still there to be improved, not necessarily from both sides, from one of you sides. So what can you do for them? What can they do for you? Goes also to Benjamin and also Thomas before, right?
Yes.
Yeah. So Benjamin, maybe you start. I see, you know, not to criticize, cleanLASER is doing a super job, but what would you like to have as a dream thing for the next cleaning, so welding experience with the, for automotive, for example, but also in a broader spectrum?
What we already have is a cooperation partner for quality assurance with 4D, so we have something going on there. But what might be very interesting is some other image correlation using the coaxial camera, because there will be manufacturing tolerances, there will be gaps, there will be misalignments between those pins, and we need to detect those. And then we need to apply a different welding strategy for this. And this might be something that we could use some cooperation partner for.
That is a very good question, because this was also in general my question. So then I put it on the floor. Tobias, sorry, I called you Thomas, but I meant Tobias. If you allow me, I put then now my question that I had in mind. Exactly, watching your fantastic videos actually about the welding and the process monitoring. That was also my question that I wanted also to address to all of you, but also especially to also from the back from Fraunhofer IFAM, because Tobias said also they have experiences there. Is there something, a part of what we heard from Benjamin, that is a must that is not there yet about process monitoring? There are special wavelengths we should check. There are special cameras that are the best ones we have to push for. So do you have there some challenges in this direction?
Yes, so the process monitoring is another story. It's completely developing, like also the laser parameters for the cleaning. And you can do a lot, but it is not so that everything is working very fine. So you have to see the case in which you want to install this monitoring tool. And for sure, from my side, I'm interested also which are the newest developments in camera technology, for example, which is able to make pictures with 1 meter per second feed speed to identify if the wire is decoated or not, to have an influence on the whole process before it is welded. And in this case, I think from the EPIC conference, my understanding is that, yeah, we have a good exchange in new technologies and possibilities. And the process monitoring is for sure one big topic.
Very good. That is exactly what I wanted to hear, because we have our members doing this. We have European initiatives like Multiple that is checking on more advanced, like hyperspectral imaging based multimodal systems for process monitoring. So everybody here listen, maybe if you want a really super fast approach, maybe there is no need to go to many bands, but nevertheless, we have everything that is possible to help you. So that's very good. And then maybe from Thomas from Fraunhofer, do you have also some other requests there? You are busy, so you are also dealing with them, right? You're developing your process monitoring yourself, or did I get it wrong? Because I remember your last slide, and this was the one thing I wanted to keep in mind to ask you.
Yeah, so partly we are developing things by ourselves, and partly we are working with industrialized systems. So it depends a little bit on the application. But we are working also very closely with cleanLASER, so we are collaborating also on some things, and yeah, so we are in good contact with each other on this.
That's a good point. I was about to forget because you mentioned it yourself. So we can maybe with one system make a lot of people happy at once. So that's very good to know. And now maybe to Tobias back just in general, because I interrupted you. This was your turn in general. What is also in general what EPIC can do for you? There is another wish, a part of the process monitoring.
At the end, it's for sure we have, as cleanLASER, we are a manufacturer of full laser systems and machine solutions, and we are looking always for the newest technology which is possible to use and makes sense for us, also to realize applications which are not running today. And for sure, the discussion about the scanner technology before was very interesting to hear. And I think, yeah, that there will be different fields to have a better understanding what is the status and yeah, what could be interesting to use and go in contact.
Yes, so remember, also if you have a last thought after this meeting, EPIC is here also to help you in this way, so that if you have something specific, of course, it's very good. You're very welcome also in future meetings to listen what are the EPIC members offering, but please always keep in mind, you can always refer to us and ask specifically if there is someone in the EPIC community that can help you. So this is for all of you, the take-home message always. So. Okay. So now it's time for another red shirt, if you see it. Is there. There is another red shirt in the room because Jose is more traditional white in OTMs. So it's my pleasure to introduce you to our innovation manager with the many years of experience in laser technology, so TRUMF, but also Quanta Systems. He couldn't miss this meeting. Look at him. He's there and he couldn't miss it. And so he's even having the question. So please, Antonio, can you make your question?
Yes, thank you, Francesca, for the nice introduction. I have not only one question. This is just a long list of questions. So maybe I try with, I select just one.
Make
maybe
a selection.
No. I make maybe a question or a challenge I put on the table. I saw fantastic. I saw the video about the welding pool on copper. Fantastic. Great. And also on AILU. So that's a really great achievement. Did you ever took in account mixed, so weld copper with AILU? And this is a question. So yes. Put to weld together the two materials. I know it's a challenge, but yes. Frankly speaking, looking on so fine results with copper and with AILU.
Yes, we did that.
No, now why don't try?
Yeah, we did that. So it's very well possible. It's possible to do it in the classical butt weld or in the overlap weld. We had a talk of one of our colleagues at the DVS Congress last Friday. Quite interesting. So yes, it's very well possible, although the intermediate phases are challenging. So it's very susceptible for cracking, but if you apply a adapted process, then it's possible, yes.
And, yeah, probably a challenge, another technological challenge, I would say not technological, production challenge is how to check, to monitor the online monitoring of the process, because then you have to take in account a small variation of the alloys, a small variation of the preparation. I think that, yeah, there are several things to put all together and to manage online.
Yes,
so
yes,
a comment because on this.
Yeah, you're right. So it's challenging. Well, we have the advantage due to the fact that we weld in vacuum. We have less influencing factors. So this makes our weld very stable in comparison to welding at atmosphere. For example, we do not have this vapor plume above the capillary. So the penetration depth is very, very stable and smooth. But you're right, in the case of alloying materials, well, usually you use very pure materials like the grades 99.5% of aluminum and CuETP. So this is usually quite good, but yeah, you're right. It might be that you have some different contents that that increase the absorption, for example. So if you use COSN6, for example, the penetration will be much higher, and this would lead to cracks, certainly.
Thank you, Benjamin, and thank you very much, grazie mille, Antonio. We go from Milano, where Antonio is based, all the way to a person who means the world to EPIC. We're going to go to one end user in the restoration, in the laser-based restoration segment. Giancarlo Calagno, grazie mille. Thank you so much for joining the meeting today. We have a lot of technologies, but we are interested in what you need. Could you tell us what you do and what is your interest in laser cleaning for restoration?
Oh, yes. You hear me?
Loud
Yes.
and clear.
Okay, I have a good experience in the with the laser in the fine art, but my English is very bad.
It's good, okay. Very good.
And in this a lot here, I use it with successful with the laser neodymium YAG and erbium YAG. With one parameter very important for the fine art is the no more the frequency, no more the power, but is a dual impulse. The dual impulse of a wavelength is very important to have a good contact on the surface, like painting, like stone, like metal, so on. So very interesting to know how to control the fluence better than in this moment with the ancient laser like erbium for painting or neodymium YAG for the stone or metal.
Giancarlo, there is a company in EPIC which maybe you already know because it's located in Italy, and it's called Lithium Laser. Alessandro is one of the key people that we have in our network on controlling the power by reducing the lights, the pulse size, the pulse length. Alessandro, did you already explore the market of restoration? What is in general Lithium Laser doing in laser cleaning?
Actually, not yet. We are here today and we sponsored the meeting because we wanted to know more on laser cleaning, and that's why we are here. So, but yeah, of course, I'm really open to talk directly with Giancarlo in order to understand better its expectation from the laser technology and how maybe we can help him solving his problem.
I don't think we can reveal the projects in which Giancarlo is involved, but if you like art in Italy, you will be very, very impressed. Grazie mille. Thank you very much for the both of you.
We're not so far away.
Thank you very much for the both of you. But I also would like to go now back to Matthias, back to Qioptic Excelitas. Matthias, what's on your mind?
Yeah. So thank you for the presentation. You've talked about 200 to 500 watt laser power. And I think we all know different materials need different wavelengths. So aluminium, copper, and combination of aluminium, copper. At what wavelengths do you work, do you process?
Yes, thanks for the question. These laser units are in the near infrared wavelengths area, and we have the experience that it's very good to treat, especially copper and aluminium with these wavelengths to remove dirt, coatings, whatever, and yeah, to not modify the substrate itself too much.
And for welding?
For welding?
We only use our infrared lasers, so single mode fiber lasers usually in the case, because it's not a matter of wavelength in our mind, but it's a matter of intensity.
Yep.
So if you have the right intensity, you can weld also copper with the single mode fiber laser of 500 watt. So if the focal diameter is just 30 microns in diameter, this is enough to get a deep penetration welding.
We go, okay, you know, this meeting, Matthias, you know, this meeting is global. So I'm going to cross the Atlantic and going all the way to the Senai Institute in Brazil. Tiago Pereira is one of the laser experts in laser texturing for surface functionalization at the Senai Center. And if you know the Senai like me, you know that they are very well connected in the Brazil industry. Tiago, I know you're a big fan of EPIC. You came to a laser meeting. What kind of collaborations, cooperations can we start with the people here?
Yeah, sure. Can you hear me?
Loud and clear.
Okay. So thank you for the opportunity. It's really amazing for us to be able to keep up with the technologies and new applications from you guys. So these meetings are really, really good. It's the first one that I was able to catch live, so it's a very nice opportunity. So yes, I work specifically with laser surface functionalization, and today we have one project in laser cleaning in the oil and gas industry. So we're trying to using robotics to apply the technology in this industry. Our main problem today is really cost and productivity, so speed of processing.
And by speed of processing, do you also mean the scanning as a challenge? Is that one of your main challenges? Because there we really can help.
Well, not really speed of scanning, but the process itself. So preparing the surface, for painting in general. So today we are achieving 2 to 3 meters squared per hour, both cleaning, surface cleaning, and creating a pattern for painting.
Thank you very much. Obrigado, Tiago. It's great to have you here with us.
Thank you very much.
I want to also go now to the YouTube channel because I have a question from a company that makes me extremely excited. Water-based, laser-based manufacturing all the way from Switzerland, Sinova. And Jeremy Deboni has a question for the excimer laser community. So I have to look at Ralph from Coherent. The question is, are excimer lasers well suited for rubber cleaning?
Rubber?
Rubber, yes.
Oh.
Do you have any project in which rubber would be suitable to be cleaned with the excimer laser? In terms of power, yes. In terms of power, it would be the right power, the right pulse. In terms of space as well, do you know any success story?
Not specifically, I have to say. I would think so, depending on what's the contaminant. But I don't know. Maybe Thomas has some experience, like from.
No, I'm sorry, no, but I would say the same thing. So it depends on the contamination you want to clean from the rubber. But no, we have no stories from our institute. I'm sorry.
Not from excimer lasers, but I would like to say Jeremy Deboni from Sinova in Switzerland. We have success stories in APIC on rubber cleaning, and one of the most beautiful success stories in rubber cleaning comes from the German company Jet, who also is the 3rd out of 3 success stories we wanted to communicate to the world today. Jan Flohre, thank you very much for taking the 3rd slot and the opening for the great debate session that's going to happen after you, the floor, and the attention of everyone in the world goes to Jet.
So much. Thank you so much for the introduction. Please let me know if you can see my screen.
Let us see this on the way. After this presentation, I would like to have a nice debate between all of you on ways to working together. So I will go to Riedel Cooling, here from represented by Karsten. I will go to OFS. I will go to Eric from SLCR. I would like to also understand a bit better what kind of cooperations we can start with the optics manufacturer, asphericon and power photonic. Also, would like to hear from Schott. We will have a nice debate after this. Jan, how is it going?
Oh, can you see my screen?
Not yet.
Not yet. Also, then wait. Then please.
Bottom of the Zoom window, there's a green arrow up. You press it, and more very important, you click on the screen that you want to share. So after pressing the arrow, you need to click on the screen that you want to share. It will ask you, will offer you a set of. There you go.
So
fantastic laser processes, fantastic screen sharing. The floor is yours.
Okay. So and you see it in full screen?
I think I will see it in a second in full screen. Can you click there? Yes, we see it perfectly clear.
Perfect.
The floor is yours.
So thank you so much for the kind introduction. Yeah, today I will introduce the Jet company, the handheld cleaning system, the Jet Laser. And before I start, I would shortly like to introduce the company Jet. So Jet is a company also based in Germany, And we are separated into two business units. One is dealing on the tire manufacturing and general automotive sector. There we have these large cleaning systems for tire mold cleaning, which you saw in the beginning in the introduction, the full automatic systems. But we also have machines for marking tires or for traceability or quality inspection. For example, we shoot these QR codes on the tire rims. We have the general cleaning systems where we provide turnkey solutions in the general industry. And we have the second part of the company. It's called MicroTech. There we have solutions for laser cutting and drilling, as well as laser patterning of glasses and thin films for especially the photovoltaics or thin film photovoltaics. And there we have turnkey solutions for processing square meters of glass. We have also a micro machining job shop, as well as a new business where we do surface functionalization on large scale. And today I would like to talk about the jet laser, which is a part of the ForJet technology on the general laser cleaning. And the applications that can be done with these handheld system is definitely is the mold cleaning, what you saw also in the beginning. But it's also possible to do paint stripping, surface roughening, rust removal, or degreasing. And later on, Kevin Harrison will give you some examples from his company. Let me show you the product range of the jet laser. So we have 4 different models, and they all vary in size and weight. And we are starting with the smallest one, which has 100 watt, and it goes up to 1000, so 1 kilowatt. And the smallest one, it has a size a little bit smaller than a washing machine. It has a storage for the handpiece in it. And it has a 2-phase connection from the power supply, 5-meter cable. And the large ones, the M200 to the M1000, they all come with the same supply wagon, and they have 3-phase connection and different fiber length. Let's now have a look. All our jet laser systems, they have a rugged supply wagon and come on lockable industrial caster wheels for the mobility. And all systems are self-contained. That means that you just need to plug them to the power supply and then you can start working. And they are self-contained. So they have a chiller inside, expect for the M100 with 100 laser power, we just have an air-cooled laser. So they come with a power supply, and we always use maintenance-free nanosecond pulsed fiber laser sources, which are optimized for the cleaning. We have the controls and the touch panel, and we have the handheld scanner. And since the handheld scanner is the connection between the human and the machine, here we have one slide for the handheld piece itself. So the design of the handpiece, it is made in the way that it's ergonomic and symmetrical. So that gives you a more safer and comfortable and also accurate processing. And we also choose to operate it with in a 2-hand operation system. So just to have a safer processing. And the 200 to 1000 watt models, they all come with a 1D scanner, and the 100 watt model has a 2D scanner, and there this provides versatile scanning patterns, and one finds a scanning strategy for an optimal cleaning result with those ones. When thinking about different applications for laser cleaning, it is often necessary to change the fluence. And with our system, it's very easy to change the lens. You can just easily open the quick release at the end piece, and then you have access to the lens and can change that to different focal length. And since different applications need different energy densities, you can change the lens within seconds and change from one application to the other. And so you enlarge the field of application. You saw it. There is laser coming out directly at the human. So the jet laser is a class 4 laser system, and therefore it's mandatory to wear laser safety equipment to protect yourself and also the surrounding by shade the area. But the system comes also with an interface for a connection of external devices. So we have secured input for customer e-stop or interlock or laser warning light, and we try to choose components with safety performance level D for safety. And we always try to improve the system. So we are always looking for new challenges for better laser sources and scanners. And yeah, in overall, now I would like to hand over to Kevin Harrison from Project Laser. He's using a 500 watt laser system from Forjet and will give you the information from his cleaning projects. Thank you very much.
Thank you very much, Jan. Now let's see if Kevin is still there. From Australia directly, not asleep yet, right?
I'm through. I'm in the middle of Australia somewhere and there's shocking signal.
The floor is yours, Kevin.
Hello. Can you see my screen?
No, we don't see it yet. If you do it, maybe you restart from the beginning. You have either to choose the screen still, or we just start from scratch and you can see if now it's coming. Yeah, now it looks better. Something is coming.
I believe. Can you see that? I think my signal is a little bit choppy and dropping.
Yeah, let's do like this. We share it for you. Let me check if we can do it now quickly so that you can just speak and tell us when to change the slide.
Yeah, no worries. Sorry about that.
If someone is faster than me, of course, of the team, let me know. Otherwise, I'm going there. So I am there. Takes a while. Now I believe you see it with the eye. Remove
yes, I can
your
see
faces. There is probably a shadow. Let me remove this.
Right.
Okay, there you go. I choose the slide for you.
Sorry about the technical issues.
No problem.
Yeah, we can flick onto the next screen. Yes, so I'm from Project Laser. We're a West Australian company. That's basically what I'm going to go through in the next 6 minutes. I'm going to say what we do, a couple of laser cleaning challenges, and then some ideal target markets. You can go to the next one. So yeah, we're Project Laser. We started off life in Perth, the most isolated city in the world. And about 2 weeks ago, we've moved to Kalgoorlie, which is one of the mining central towns in Western Australia. There's about 100 mine sites within 500 kilometers of us. So it's quite a hub for industry. So we're a holistic, high-spec industrial laser cleaning service, which means besides being able to point a laser at something and clean it, we also take extraction and laser safety very seriously. So we've got a good quality extraction system, and we put good screenage up to protect everyone around us. And we're also the agent for Forjet LaserSystems, which Jan just spoke about. And yeah, they're fantastic systems. We're happy to represent them within Australia and the wider world. You can flick on to the next one. So we are a contamination coating corrosion removal company. So you'll see in the back of the truck there, we've got a 500 watt laser. To power that, we use a 3-phase generator. In the back left, there's another generator, which runs our compressor and extraction unit. And then we've got a bunch of screens and face masks in there. So we need all that equipment to cater to the commercial, industrial, mining, and oil and gas sectors that proliferate around us. I think we're in one of the luckiest areas in the world to have a laser cleaning business because it's incredibly prosperous. Due to having a laser in the back of your truck being a relatively new phenomenon, there's lots of testing and market creation that goes on, as you can see with those pictures there. Go to the next slide, please. Yeah, so this is going to be a couple of issues with laser cleaning. When you solder a machine or when you research machines, they often say they're there to remove oxides and paint, and that's two of the things that I basically leave last to do. So nanopulse lasers, specifically top hat lasers, they don't have the punch to remove thick layers of corrosion. As you can see with these two examples, basically those thick layers of corrosion that I could just flick off with my fingers. If you pass the laser over that, it doesn't have the abrasive power to remove it. On the far right, you also see black rust. These little black dots, that's what happens when the iron contamination basically is forged back onto the surface, and that then becomes really hard to remove, and it's also unsightly. So the underlying surface is not ready for coatings or anti-corrosion treatment. So what should you do? Next, please. Yeah, so target thin layers of corrosion. So flash rusting, light rust, or localized paint corrosion removal. So some examples of that, gears and pinions, which you see on the bottom right, milled surfaces, stainless steel and aluminium, which naturally have very thin layers of oxides, NDT surface prep, as well as tooling and machinery cleaning. When you clean those surfaces and you use good quality extraction, you end up with a very clean surface that's ready for anti-corrosion treatment or a paint coating. So it's always imperative, if you're removing corrosion, that you're also extracting away the particles, because otherwise you're just getting oxide to go up in the air and fall back onto your item, and it's just going to corrode again. So you need to have good quality extraction when you're cleaning steel. You go to the next one. Paints, the exact same problem. They're not designed, nanopulse lasers aren't designed to cut through layers of paint. So that chassis, for example, I wouldn't clean it. I would send it off to a sandblasting company to clean, because it's just too much of a large area and it's generally thick paint, so it's going to be tough to remove. Lasers are hugely affected by color, thickness, reflectivity, and density. And yeah, so as I said, your cleaning rates are going to be slow and you'll be unable to do large areas. So as a result, we flick on to the next one. It's best to target thin layers of paint or localized paint stripping. So on the right, or on the middle top, that's NDT surface prep. So you're basically just cleaning between 30 and 160 mil band over welds so they can do an inspection. Thin protective coatings, graffiti, anodizing, magnesium sulfate coatings, they all come up really easily with lasers. As a result, you end up with a clean surface ready for a reapplication of paint or an anti-corrosion coating. We can go to the next one. That's better. What contamination should you target? Light contamination layers, which can be found as flash rust, soot, films and residues, and glues. So down on the right, we have a bunch of real life applications. As I said before, stainless steel, titanium, aluminium, very easy to clean with a laser because they have light levels of oxides. Fire damage remediation is a target market I think everybody with a laser should look into, because you're basically just removing soot off walls, doors, painted surfaces, chandeliers, whatever you like, really. Molds and presses, very light levels of residue, and 4Jet are fantastic at cleaning those. Turbo machinery and tank cleaning. If you've got a top hat laser, these are great applications with a very positive return. And then statues and artifacts. So the Notre Dame Cathedral used lasers after it burnt down. Sydney Harbour Bridge, Jefferson Memorial. So there's lots of applications for lasers with artifacts and statues and historical components. Graffiti, cooling fins as well. So if we go to the next slide, we've got a few pictures. The central one there, you can see fire damage remediation. So you can probably do with a 200 watt laser 4 to 5 square meters an hour. With a 500 watt laser, you could do 10 to 12 square meters. The top right, we've got improved NDT dye penetrant results after the lasers passed over the surface. Bottom right is cleaning the heat affected zone on some stainless after welding. And then middle is an IGV inlet for a gas turbine, I believe. That's that.
Thank you very much, Kevin. So I managed to do a couple of things at the same time. I'm proud of myself, but I'm actually prouder than both of you. Thank you. Thanks a lot also to Jan and to Kevin for this other success story. So now I would say, I know that Jan, without putting in the slide, already said very quickly, maybe we can have, we consider new laser sources and faster scanners. Yes, I got that. So that let's highlight this as, let's say, what the audience can do for you, Jan. But now talking to Kevin. So Kevin, when I hear about sandblasting, I get like a shivering in the back. And so we definitely don't let you send anymore any chassis to a sandblasting place, because we want to solve this with lasers as well, right? So I assume that what you have from Jan, so you talked mostly about these handable devices. We heard also earlier of a bit larger devices. So I see there is also a throughput issue, right? I mean, you mentioned also other issues, but you can do it probably fast as well with lasers. So now is a bit my word to the audience today. So is there someone who wants to convince Kevin not to use sandblasting anymore? Well, first Jan, Jan as well. You have the right to speak first.
Yeah, thank you. I mean, Kevin also just mentioned he uses a top hat laser source, and the top hat is designed in the way that one has very fast ablation rates, but it does not so much damage the surface. So, in my opinion, one has to go more into a Gaussian beam profile, and then it is also possible to remove thicker coatings or even metallic coatings. But I think we all know that it's much slower this kind of process than some others. But technically, it's definitely possible.
Very good. So now just to be fair, Tobias, do you want to add something about this? Also, Thomas, with your experiences, if you want to throw a word in the room about this.
No, I think the difference between top hat and Gaussian beam profile knows everyone very well, and for sure, the spot is smaller, the slower you are. Also, you can remove thick contamination layers. This is the truth.
Okay, very good. And now we have Antonio, right? Our innovation manager has a couple of questions to the speakers.
Yeah, I have just because I didn't from the presentation, which is exactly the type of laser? I think that it was infrared laser, but it is a diode, pulse diode, or fiber laser. And also, which is the pulse duration in frequency? Because it looks very fast, very high frequency, but I didn't got this from the.
Yeah. So it is a fiber laser. You got it right, and it's a nanosecond pulsed fiber laser. And the one that Kevin has shown us, it has 500 watts. So in the end, it depends a little bit on the frequency and the pulse energy, but it is in the kilohertz region.
So it's a fiber laser nanosecond. We speak about 50 nanosecond plus.
Exactly.
20 to 50.
Exactly. It's in the range. So let's say between 50 to a little bit more than 100, typically.
Pulse, energy per pulse, not too much. I would say.
Not as we have heard in the beginning of the excimer lasers. It's definitely lower. So we are limited to the fiber.
Yeah, it's okay. But probably this is the limitation of the fiber laser. Did you ever try to work with diode laser? We have several companies in EPIC making strange diode laser. So direct diode.
No, actually not for the handheld systems.
Sounds like a good plan. Then we have for sure someone to introduce you that can let you test if that is a way to go for some particular solution. So keep this in mind, Jan.
Yeah, thank you.
Now, if I see you, there is no other questions because I have Jose here that we have to keep it quiet, but it's not possible anymore to keep him, right? Jose, I know you want to throw some topics for discussions into the audience, so I give you the floor.
I think it has been a truly fantastic meeting. We have 20 minutes that I would like to use for connecting the companies a bit further. So one thing that for me is very important is satisfy the needs of some of our system integrators. I know that tonight that Tiago Pereira came to the meeting with a specific request for a certain wavelength of a certain laser. Tiago, the whole EPIC community wants to help you. Do you have a request, an item in the Santa Claus Christmas list, a laser that you came to the meeting looking for?
No, today we have one laser that we are developing, right? The process. So we are limited to what we have today. So I'm not really sure.
So I understand that you're looking for a 1064 nanometer laser?
No, that's what we have, yes.
That's what you have.
2 kilowatts, 150 millijoules pulse laser, yeah.
I
so
think
it's actually really similar to what Kevin just shown, right? Our problem is really similar. Even if for his problem, the paint application, maybe a continuous wave would be quicker, maybe. We haven't tried it yet, but it's something we are looking into.
Have you evaluated, Kevin? Have you evaluated the continuous wave?
I have not evaluated them. I just see them flooding the market. Continuous wave lasers are getting sold on every website possible at this point. But no, I haven't looked further than the videos on YouTube and LinkedIn and that sort of stuff.
Well, all right. So for me now, I would like to start from the beginning and start when we started talking about the excimer lasers. When we talk about the excimer laser in the beginning, your request here, Ralph, has been very clear. You want to further industrialize the research that you're doing with Fraunhofer IFAM, and it is clear that you're going into the robotic industry, robotic arm. So you're looking for the miniaturization of the coherent module. Could you give me one or two of your headaches that I can actually use in the EPIC knowledge and the people in the room, maybe match them with some capabilities for the further miniaturization?
Yeah, actually, we're more or less at the beginning together with the IFAM Institute. So I think what is really needed is really the automation and really to drive it further, to show that it's a viable technology. And of course, also on the IFAM side, the process development goes on. And there's of course, say, customers behind which are interested into that, that you really have to get the system technology going. And so that's very exciting for us because it's I mean, normally everybody says, okay, an excimer laser, you also said it in the introduction, it's too heavy, too big, you cannot use it for any type of scanning or maybe robotics. But I think we are really here at the verge of showing that and what is possible. And so we really have to close this gap between showing the possibility and finding the business case and then also make it to the real world. And I'm really looking forward to it. And we're looking forward to any input from your side?
When it comes to automation and precision, there are many companies in the network, but in general, there's a company I'm very fond of. This company comes all the way from Switzerland. It's called MPS, Micro Precision Technology. From the MPS side, Eugene, you have been listening to quite a lot. You have been spotting some room for cooperation. What kinds of cooperation can we start with people in the room?
Yeah, hello everybody. So do you hear me? Yeah, I think so.
Loud and clear.
Yeah, thank you. Yeah, MPS is a micro precision systems supplier. We are developing motorized optomechanics, and so I think there are a lot of ways what we could develop, because I think more than 90% of our systems are customized and customer developments, and that's really often goes really small. So I think there is some potential if it's something micromechanics, in some cases maybe a bolt screw movement, which has really to be stick slip free and without almost any friction or something in this direction. And yeah, I had also one question to Jan, as I saw your presentation in the beginning, and you were showing that to change the parameters, you are exchanging the lenses, for instance. So would that be maybe interesting? So I'm not an expert in optics, but theoretically, would it be possible to keep the same lenses, but just to move them?
Yeah.
Motorized, so maybe it would be easier just to push a button and the parameters change without exchanging the length.
Yeah, you are totally right. This is a good point. And this is also something that we do in our fully automated machines. You always have to find a trade-off between the weight of the handpiece, because you have to handle it as a human, and the functionalization, so everything what is inside. And for the jet laser system, we had to look on have it as light as possible to make an operation possible for 8 hours a day for one person. And everything for the optics, movements or beam expanders or whatever you can think of, is just more weight, but it is definitely possible, and it's a good idea.
Fantastic. Further integration of the lenses. So we have a company in the room, Netalux. Emmanuel Flam. Emmanuel, can you hear us? If you can hear us, raise your hand, unmute, or open your Mac camera. He cannot hear us, but we are sorting out. My team is contacting.
Yes, I can. Sorry.
Yes. Can you also switch on the camera so we can see you as well?
Yes, sure. Hello.
Hello. So you have already successfully integrated your lenses. Please tell us about this and how we can cooperate further with the members.
Yes, correct. We have actually thought about those systems from a user's point of view, and that was one of the things that we first developed, is to integrate different lenses in our systems. It allows for the system to keep closed actually during works on site, and switch lenses by the push of a button indeed.
If you could spot some room for cooperation with the members today, what kind of things could you do together? Which kind of companies would you like to follow up with afterwards?
Well, it's very interesting to hear the discussions that Kevin, Jan, and a couple of other people were raising. I think one of the main developments in laser cleaning in the world is still increasing speed, and it's interesting to hear from different companies that everybody's working on those different possibilities. So we are looking at the market developments very closely, and we hope to see new developments in terms of sources and different possibilities of speeds to clean larger sizes of surfaces, because we certainly feel an increase in demand of the market to clean larger surfaces with more difficult contaminants.
I would like to go now quickly to LavaX, Benjamin Gerhards. Benjamin, thank you very much for the great presentation. I'm a big fan of what you do. What I'm getting so far from what Ralph presented, also a bit from what was presented by Jan from Forget, is that the main challenge seems to be more into the scanning more than in the beam shaping. Is that correct? Are there some some challenges also on the beam shaping that we can actually discuss with the people in the room.
So scanning is very important for us because all our machines are equipped with a scanning head. We usually work, for example, with Weichert, and this is very, very important for our process. But beam shaping could also be of a very high interest due to the fact that reaching very high velocities might require another beam shape. So we're kind of looking into this as well, but we haven't done this yet. So it's something that we want to look into in the future.
You know, when it comes to beam shaping, I have a very good friend in the network who has a fantastic educational YouTube channel, but also is the contact point for the company Asphericon. Sabrina, Matthias, you heard about the challenges that companies are having. What do you get as a room for cooperation? What kind of introduction you want to ask after?
Do you want me to share the screen now?
Always, always. I always want you to share the
all
screen.
right. Yeah, I think beam shaping is or should be of interest to everybody who is working with lasers. And you already made the introduction in the beginning that, sorry, you see screen now?
Yes.
That asphericon can help with freeform optics and with high-performing optics and objectives. But what we also can offer are beam shaping elements. And one of the beam shaping element is our airy shape that can turn Gaussian light into top hat light. And this is something that we have off stock, but we have a very good team that can help with designing beam shaping solutions. Sorry, my little one is climbing right behind me. So you can come to us with your challenges and what is the incoming beam profile, and then we can see if there's an option that we can really design a beam shaping solution for your needs. And also, we have a new element coming soon that can help to do beam shaping right in the rectangular, in the squared shape, which we heard in a lot of talks already, that a squared shape is even more convenient because it helps to make the whole process more efficient and helps to don't have any overlaps in your weldings or in your cleaning. So I think this can be something that can help lots of you out there for your applications. But this is something that is coming soon. We have proven the functionality, and this will be a stock element. So this is very convenient to people working in that field because you can just offer it off the shelf and try it, and you don't have to wait for it to be designed and to be manufactured. It will be there and you can try it.
Fantastic. And here I would like to revisit the topic. When I go back to Jan from Forget, we discussed in a previous meeting fully dedicated to beam shaping, we discussed about some challenges specific to laser cleaning. I know that we already are going to say different between Gaussian and flat and top hat. Please don't answer on that direction. But there is still some challenges, Jan, for beam shaping in the laser cleaning market.
Yes, there have been challenges. It is not only dependent on the beam shape itself. It's also the fact that you need, in the end, a high energy density for some applications. And for example, if you have just not enough pulse energy, and you put that beam into a large top hat, then you end up in a very low energy density. Then you can scan fast, and you have a very high scanning rate, but you might not have enough power, or at least energy density on the surface. So one needs to find a way either to increase the pulse energy, or to have a very small spot.
Just if I can mention something on that, the elements that we offer, they give you all the options. So you can have a top hat, or you can still have your Gaussian beam, or you can have a donut beam in the focal area of your lens. So you can find them all together in one setup. Does that maybe help for some of you? So you can still go back to the very high density where you can go deeper into your material, but you can also go to the top hat if you want to have the process just quicker, because you have, let's say, a thinner layer to remove. Because what we saw, what Kevin introduced, there were those elements that had very thick layers of rust. And then you also had areas where you only had very thin layers of rust. So you could maybe switch in between by just implementing one element.
Mm. Yeah, I totally agree that that would be very, very nice to have that. I'm not sure, but I made the experience that when that you have the real beam shape just on one certain position, and I mean you have to think this is when you're using a handheld system, you not always have precise working distance, and if you then change that, you end up in a donut or in some other figure, and it's a perfect system for the automated machine.
Yes, I agree. I agree on that. Yeah, handheld is difficult because it's only in the size of micrometers where you find those different. But maybe you have an option where you would need such things automated, as you said.
Yeah, thank you. Thanks a lot for that presentation, because there are definitely more applications at ForJet where we can use those kind of optics.
So one thing, thank you so much, Sabrina. You're always the star of every show. Thank you so much. Jan,
yeah, sorry for the little one.
Oh, no, please. He's a co-star. Jan, one thing that is really important as well, beyond the optics, is, of course, the coatings that need to be applied. On that, we already discussed quickly with Optoman in the beginning. But do you see any challenges also in the coatings needed on those optics?
I mean, we usually have a very common wavelength with the 1060 or 164. We always have the problems of back reflection, and as better the coating's getting, as less back reflection one has. So therefore, it's always good to have a very, very good coatings.
All right, so on that, we have lots of challenges in the room. There's time for 2 more challenges. I want to go first to the Axicons of Power Photonic, which is a company that has grown dramatically in helping the laser industry with the shaping of the high power lasers all the way from Scotland, UK. Paul Blair.
Hello, thank you very much. Yeah, so Power Photonic are also making freeform optics, lots of beam shaping applications, and one of our range certainly is Axicons. So we do quite a lot of Axicons for quite a lot of different companies and different industries. I think one of the things that's interesting, and it picks up a little bit of what Sabrina was saying there was I mean, also Jan, is I think the collaboration perhaps still needs to be a little bit closer between those of us who are supplying into those of us who are using. Often what's happened, and it's very disappointing for all of us, is something is ordered on the expectation it might work, but there's no communication. It's tried, it doesn't work, and then the whole thing falls down. So come to us, talk to us. Let's join you in your journey.
That's what we are here for. And I have to say that if you need the optics from Power Photonic or from asphericon just to test them, to try them, I pay for the shipping expenses and I don't expense it to the EPIC members. I pay myself. I really want this thing to happen more often. Jan, Benjamin, Ralph, let's make it happen. The optics is one thing, the coatings is one thing. One important thing as well is the fiber. I would like to go to our EPIC member on specialty fiber solutions. We have OFS represented by Udo Fetzer and Jeff Nicholson. I'm going to give first the floor to Jeff and then to Udo. Jeff, what's on your mind?
Sure. So I'd like to thank the opportunity. Can you see my slide?
Yes, crystal clear. You go slideshow mode, presentation mode, and then I see it even clearer.
Sure. So we just wanted to quickly introduce some of the technology that we've been developing in fiber laser sources, in particular, very large core fibers designed for these types of high pulse energy applications. where, you know, the applications we've already discussed, we don't need to go into that. But we've introduced to the market our True XMF 200-375 optical fiber, which is a 200 micron core optical fiber designed for kilowatt average power applications with high efficiencies and low thermal loads. And this is based on some of our proprietary MCVD process, which helps ensure the high purity and high reliability in the core rods, which then gives us the efficiency, the low photon darkening. And at the same time, we're also offering matched pump signal combiners, mode field adapters, passive fibers, all the components needed to build fiber laser systems for these cleaning applications. But more importantly, we're also offering what we call the True XMA multi-mode amplifier module. And this is really designed for the people who don't want to delve into the specifics of building fiber modules. And it's really designed for OEM laser manufacturers to put into their systems and for rapid prototyping. So the sort of question for the folks on the meeting here is, what are you looking for in your fiber lasers? How can we work with you to sort of optimize our fibers, components, and modules for your applications? So thank you.
Thank you very much, Jeff. And Udo, you get the honor of being our closing statement reliever, and then I will close the meeting.
Okay, thanks for this honor, Jose. Yes, as Jeff said already, we have different active fiber components around fiber lasers. And we are very happy to collaborate with companies here in the room and, of course, other EPIC members in terms of early stage co-development. So we are very happy to share information in the beginning of a new project and contribute with, let's say, optical components.
You know what I think? I think that in a meeting in 2 hours, in which if I ask individual, I already did in the chat privately, all of you will already connect with somebody else. In 2 hours, you generated one lead. I was last week at a conference, in a real conference, present meeting. I was there for 3 days. Most people didn't generate one lead in 3 days. This shows that there is a challenge to continue on the live and the real event, and we will continue with the online and real events at EPIC. Today, for me, there were 3 success stories presented, and most important, there were main challenges discussed with the industry. On one hand, we had the laser scanning challenge. On the other hand, we had the adaptive beam shaping for different contaminant removal. Thank you for that challenge. You're going to be introduced to many of our members. And the process monitoring, which was expressed in the beginning as a challenge, but we have a dedicated meeting for that one. So that's why I don't put much into that dedicated meeting for that one. Until the next time, that was Francesca, Moglia, Antonio Raspat, fantastic EPIC members, and myself, Jose, always at your service. And that concludes the public part of today's meeting. If you are in our Zoom room, our informal private discussion is about to start. I call it virtual drinks with friends. And we all know follow-up is important. But for now, if you are watching on YouTube, that's where we leave you for today. Thanks to the EPIC production crew and our sponsors for making today's event possible. More details about upcoming meetings are on our website. And if you want to get in touch with any of the participants, all you have to do is contact me directly and I will make sure you get introduced. It is all about connections. Thanks for being EPIC.